Before I get started, if you have questions, thank you. If you have questions, I'm very open to having them shouted out or typed into the chat. And Jamie, if you could sort of monitor the chat if there's a question and let me know.
Oh, don't worry, we've got that all well sewed up. So yeah, we'll keep an eye on that. And the same for the people in the room. If you've got any questions, just sorry to sound old school, but pop your hand up and we'll make sure we get those over to Ray for you.
Okay. So today we're going to talk about mainframe integrity vulnerabilities, and basically at the end of our talk here, hopefully you'll have a better idea of what the topic entails and have some basic groundwork to help you understand what they are and remediation and all that. One thing I'll talk about right up front is that when I talk to people about mainframe vulnerabilities, I find it very, very helpful to talk about the source of vulnerabilities, right? And what I mean by source of vulnerability is that typically vulnerabilities are caused by one of two things, right? Either a configuration problem, right? And I typically call those configuration-based vulnerabilities, or it's a code vulnerability. In other words, some authorized piece of code in your mainframe has a design or logic flaw that when executed, and you pass it the right parameter list, will pierce the veil of the system integrity and allow you to do things that you're not supposed to be able to do. Today, we're going to be talking about the code vulnerabilities, right? We're not particularly going to be talking about the configuration-based vulnerabilities. Although if you have questions about that, I'm happy to entertain them. So when I talk about ZOS integrity, most people, unless you think about it, don't realize that the reason that the mainframe is so secure is that there's this concept of integrity. And I like to talk about, the engineers when they, cranked up that first computer and ran that first program, right? They just had, real memory, not virtual memory, and they loaded the program and they wanted to execute it and they were all excited, and, the program ran and they got their results, whatever it was, that probably the next thing they were thinking about doing, it's like, well, gee, I got this big hardware here. I want to run multiple programs simultaneously. And this idea of integrity came from trying to solve that problem where you have these multiple programs all executing with the same set of resources, and you wanted to make sure one bunch or one program didn't step on or affect another one, right? So they had to have this concept of integrity in the environment so that both programs could run simultaneously and they would produce consistent results, right? Well, that was the early days. These days, right, with the mainframe, the controls, the integrity controls that ZOS puts in place has to remain intact. If those controls can be bypassed, pretty much you can't secure the mainframe system, right? So the ESMs, ACF2, RACF, and Top Secret, they're not responsible for integrity. The BCP or ZOS itself is responsible for integrity, right? And from a capability or, capability attribute sort of standpoint, right? The program property tables, APF, bypass, password protect, right? Those are all ZOS authorities, if you will, and they're controlled by the BCP and have nothing to do directly with your ESM, whichever flavor you have. Now, certainly your ESMs have a requirement for integrity for whatever they're doing, right? But if somebody is able to, for instance, mode set and get into key 0 and then flip the JSCB off bit so that they can APF authorize any data set, that's not something that the ESMs currently are looking at today, right? So it just helps, I think, as you're going, as we're going through our pitch today, that just keep that in mind. Code-based vulnerabilities, not configuration, right? The remediation for a configuration-based vulnerability is a configuration change, whatever that means, right? Which is different from a code-based vulnerability remediation, which is a patch, right? Now, somebody's going to be thinking here, gee, there's got to be a configuration switch that turns something off. And I would say in the last 14 years, I've had one instance where we found a vulnerability, happened to be in an SVC program, that they decided to remove the program. Typically, for instance, if it's part of the BCP and you IPL and you have the vulnerability, or product A that you've installed and are dependent on, turning it off or removing it's typically not an option. So pretty much patching for code-based vulnerabilities is what you need to do, right? Right, there are different sources and there's fundamentally different remediation that you have to go through. Anyways, system integrity in our talk today is the ability for the operating system to protect the data and its processes from unauthorized changes, right? You wouldn't want just anybody to be able to set bypass protect or to make their program be in the PPT so that it can run in, special key or bypass password, that sort of thing, right? Or allow any APF authorized load library that you happen to allocate to be APF, right? So, but it also is included, in the ESM, right? You don't want to be able to have a vulnerability in there where you can dynamically elevate your ESM authorities, right? Different authorities in RACF, top secret, and ACF2, of course, but dynamic elevation of authorities is a typical exploit target for the mainframe. So the ZOS was architected with integrity in mind, and it's really, really critical, right? You can't have security without integrity, right? If there's a authorized code path on your machine that anybody can issue, and if it's an SVC, you just have to be able to issue that SVC, right? If it's associated with CICS or some application, you don't have to access the application, right? It's just an operating system function that was either designed or coded improperly that, the bad people can take advantage of. So, and that's the kind of scenario here, right? It's related to the operating system integrity. Unfortunately, your ESMs typically can't help you. So for instance, if there's an SVC on your system, there's nothing that I'm aware of in ACF2, top secret, or RACF that says, Jamie, you can't issue that SVC unless there's actual code in that SVC to do it, right? And if the vulnerable code is before that check, it doesn't matter anyways, right? So when I say 99.999% of the time, a patch is what you need to fix the code path, and configuration changes and other actions really just aren't viable. So there's this thing called the IBM Statement of Integrity. I think most mainframers at some point get around to it. And this was introduced in 1973 and through the SHARE project in the States. And basically the SHARE, it's like GSE, it's a user community of IBM mainframes. And they basically said, we think we need security, right? And they talked about the fact that they realized that integrity was important, and you couldn't bypass the controls that MVS had, or VS1 had to, and still be able to secure it. So through the discussions with IBM and the SHARE project, that was one of the things that came out of it, that the SHARE people said, okay, you have to come out with some sort of statement about the integrity of ZOS, and thus the statement of integrity was created, right? Because IBM realized, as well as the SHARE people, that without integrity, you can't have security, right? You can't secure the environment, right? There's got to be a certain set of controls. And what the IBM statement of integrity says, right? It's been lawyered up over the years, and it gets worse every time I go look at it. But essentially what it's saying is that the end users shouldn't be able to bypass the controls that you've put in place, both on the operating system side, which is, you know, IBM's responsibility, and as well as the installation side when they do an ESM, right? They shouldn't be able to, you know, bypass those controls. If you say, you know, it's a data set and you only want certain people to have access to it, they shouldn't be able to get around that, right? And so this was really, this realization way back in 1973 by IBM, and as well as the share community, was really the recognition of the importance of integrity as it relates to security, and it's why we have the secure environment that we have today. So, but in order to have that integrity, to have that really secure systems, like most things, there's some due diligence that are required on the installation side of things. And if you go look in the IBM MBS Authorized Assembler Services Guide, it basically tells you, it's an odd place to put it, but that's where it is, that the installation assumes responsibility for ensuring that whatever changes they make to their systems, and by changes, it's not just, you know, user SVCs or APF authorized code that you write. It also would include vendors that have authorized code paths, right? You guys, people routinely install software from third parties that's APF. All of those fall under the category of, hey, it's your responsibility to make sure that they don't, quote, pierce the integrity veil that allows unauthorized users to be able to dynamically elevate their authority and do things they're not supposed to do, right? Writing in, you know, updating memory, key 1 through 7 memory, right? You shouldn't be able to do that. Updating memory in another address space, even though it's key 8 or key 9, right? Technically, you know, by architecture, you're not supposed to be able to do that. So it's kind of an interesting thing that one, and this has been this way probably since back in probably 80s or 90s, right? This responsibility, it's just people didn't really realize that, you know, it's what they need to do, right? They need to take steps to make sure that their mainframes have integrity. And, you know, the combination of the statement of integrity and, you know, the installation responsibilities, right? And that doesn't mean that there aren't mainframe vulnerabilities, because there are. They're certainly not as numerous as maybe some of the other platforms. But you know, that it's your responsibility to make sure that when you modify your ZOS system as delivered by IBM, that, you know, you have that due diligence to make sure that you're not introducing integrity problems, which would then allow somebody to bypass the controls. So you may not have known that, but that's the underlying assumption, right? That integrity is important. You can't have security without integrity. And unless you run a vanilla 2.4 ZOS system, right, you're responsible for any changes you make to that system vis-a-vis any sort of integrity issues that might be introduced. So according to IBM, a security vulnerability is a set of conditions, design, implementation, operation, management of a product or service that is unable to prevent attack resulting in exploitation. And that's sort of lawyer speak, I think, for saying, okay, I put an SVC in, I put standard linkage in it, that you're not supposed to do that, and any idiot can call that SVC unless you mark it as being APF required. And you can do bad things right out of the box, right? And so, you know, this whole idea of these code vulnerabilities, right, is something that it takes people a little while to get their hands around, right? It's not like configuration-based vulnerabilities. As I went over briefly at the beginning, there's a completely different approach, right, to how you do remediation for these things. One, you have to identify them, and then two, you got to get somebody to create you a patch, because typically you don't have the source code for it, right? So understanding that sourcing, I think, adds clarity to the conversation, right? Because assuming everybody's up to speed on what vulnerability source means, and you know what that is, then you automatically know, oh, if it's a configuration-based vulnerability, it's something that we can remediate by making a configuration change. Now, it might take you 2 or 3 years to get that change put in place, because you are, after all, a company or a large organization, or maybe a government or military, and it takes time to make these changes. But it's a completely different process than what you would have to do for these code vulnerabilities, which is a patch, right? So you're probably saying, well, gee, Ray, I have no idea how I would even go about looking for this stuff, right? It's complicated, it's very technical, and people, we may or may not have people that can do this, and even if we do, we probably want them doing other things, like helping us make more widgets and sell more things, or whatever it is that your company does, right? So because of the criticality of these, the integrity, maintaining the integrity of your ZOS system, this scanning, looking for code vulnerabilities is it's really, in theory, it's no different than, looking for configuration-based vulnerabilities and scanning for that, right? I think we all know that if we wait to get a phone call at our desk at work to say, gee, there's been a data breach or something else, it's like, it's way too late, right? We need to be, as security professional these days, looking for trouble, right? Proactively scanning and looking at things, saying, hey, is the security policy for this mainframe system, is it actually what we've implemented in the ESM or the configuration parameters, right? But for the code vulnerabilities, you can do the same thing, right? As maintenance or changes are introduced into your environment, right? That's the time when most people would say, you know what, we're going to take a look at the authorized code path that are going in through these changes and see if we find anything, right? And so, each time a vendor produces a new release or PTF for their code, right? Change, just like on the configuration side, changes where it's not only an opportunity to do good things, to fix things, it's also an opportunity to break or introduce new vulnerabilities in the system, right? So having a good feel for your maintenance change philosophy and how that stuff works would give you an idea of how often, for instance, you might want to scan your environment, whether it be scanning for configuration-based vulnerabilities or scanning for code vulnerabilities. So, as I said, proactive, right? Can't wait. The mainframe's no longer this castle with a moat, and hardly, it's only certain ways to get into it. Pretty much, that mainframe is sharing data with people all over the world, right? And you can't always regulate or control within the actual mainframe itself, how they're getting in there, right? You have to deal with other systems that are connecting and getting data and doing all kinds of stuff. And by detecting the, I'll just call it broken code, vulnerability scanning provides your organization with a proactive way to alert the vendors, right? Because they're the ones that support and maintain it, right? It's having come from software development as my background, I understand that when developing a software package, that you can't always replicate the client's environment. It's very complicated and there's too many permutations. So it isn't always possible to hit every permutation and every way the code's going to be driven. And so, there's vulnerabilities that creep in, right? And I say this to people all the time, that if your product has an APF authorized code path, it's a matter of when, not if, that you're going to have an integrity problem. It's just the nature of the beast. And unless you write it once, debug it, and never touch it again, which occasionally that happens, it's just an ongoing thing that you have to keep, going back and rescanning, right? That whole vulnerability lifecycle picture, I'm sure everybody's seen it, right? You're basically just iterating through that each time, saying, okay, I just put on a bunch of fixes, and we're going to roll, we're going to clone the res and roll out into, the res cloning process. And, I'd like to scan as we go through those environments, just to make sure that, as best we can, we make sure that the integrity of our ZOS environment isn't violated. In a perfect world, the vendors themselves would deploy vulnerability scanning to do it, but to date, let's just say, at best, that's in an early stage of the game. And I've been doing this particular type of stuff for about 14 years now. I would have hoped it would have gone a little bit faster, but it is what it is. So I don't know about you guys, but I talk to developers and people all the time about vulnerabilities. And if you've ever had one of these conversations, like I had in the early days, it always bogged down into details and, the particular characteristics of the vulnerability and how to exploit and all this other stuff, that basically it was nearly impossible to have a coherent, clear conversation. And through the work, the integrity work that I've been doing over the last 14 years, we came to the conclusion that by categorizing the vulnerabilities based on their capabilities would allow intelligence-informed conversations within your organization, and it wouldn't be limited to just the sysprog and his manager, right? By categorizing the vulnerabilities based on capability, you would be able to include the C-level, audit, risk, and other people in your organization, so that the organization can make an informed decision based on what's best for the organization. So what we've got here is a particular category, and there's subcategories to this, but we struggled initially to perhaps adopt the terminology or the nomenclature from, say, a Windows or Linux platform. But since our audience was ZOS folks, we decided that that wasn't going to work well. I decided it. So those of you that want to boo and hiss, I can take it. But through these definitions, right, hopefully it will get you a sense of clarity. So for instance, we have one called trapdoor, and there's basically two versions of trapdoors. And it's not so much that it's the most severe vulnerability, but it's usually the easiest to exploit. But a trapdoor vulnerability, like I said, it has two flavors, right? One flavor is that you call the authorized code path and it'll branch to an address that you passed it, which is completely stupid. And I never thought I would see that, but we run into that about 30–40% of the time, right? So developers know about it, and developers do it even though we keep finding them and they keep having to fix them. And the ability to pass an address to something and have an SVC branch to it basically means that as a Key 8 problem state program, I can pass an address, invoke an SVC or PC routine. And it doesn't really matter if the SVC or PC routine, quote, works for whatever its original intention was. It just has to execute the, quote, vulnerable code path. And if it branches to my address and then I put something, I put some code at that address to mode set, go find my ACEE, set the trusted bit or privileged bit, or, set some ACF2 attributes, non-cancel, security, build me a new ACEE for the security officer, because maybe I want to, do some things and have them get the violations, right? It basically allows me to pierce that veil, and the integrity of this system is now broken, right? Because you have no way to control what I can do, when I can do it, other than, letting me on the system or not, right? So, but the trapdoor, right? That's one type where basically you pass it an address and it branch back to you. But there's other type of trapdoors where, again, as stupid as it sounds, it's sort of like, if you've ever heard of, they call it a magic SVC, right? So you call this SVC and you come back with bypass password protect set automatically, or you have to load something in register 0 or some other stupid thing. Or you're in supervisor state, or you're in PSW keys 0 through 7, or the JSCV auth bit is set, right? So we, when we detect things like this, we categorize it as a trapdoor, and we have trapdoors 1, 2, 3. I don't know. I think lately we're up to about TD 11, right? We have that many of them. But the really cool thing is that now by having these classifications, we can talk about that, right? So if you have a trapdoor vulnerability, you're the sysprog or the pen tester that's looking for these things, and you now have one of these things, you're like, hey, we have a trapdoor vulnerability, and your boss is like, well, what the heck is that? Well, basically it's, let's just say it's the TD1, right? TD1 says that it's a, you pass it an address, it branches to you, and key 0, doesn't matter whether it's soup state or not, right? Your key 0, you can set soup state if you feel like it, but you basically have the keys to the kingdom. And so it's not enough information for you to say, well, gee, I could write an exploit for that, right? You don't know which SVC it is. You don't, the details to do all that stuff's not there. But but the classification basically is that's the capability here, right? And when you apply the categorization to a vulnerability, it's 100% exploitable, right? People always ask, well, how do I know it's exploitable? Well, it's exploitable because, well, the process is in the assignment of the categorization, right? You have forensic evidence that would prove that. But once it's assigned, it's like, okay, it's exploitable. We don't have to talk about that. I mean, we can create an exploit if you like to verify it, but it's exploitable. The capabilities, right? Passing an address and it branches to that address in keys in key 0 in this case. With that, it's basically a backdoor in your system. You can do anything you like, bypass any controls, pretend to be anybody you want. You're basically executing as an extension of ZOS, and whatever ZOS can do, which includes RACF top secret and ACF2, you can do, right? So now, instead of just saying, hey, and I'm picking an IBM, but the other vendors are basically the same, right? IBM has a patch that basically, is an integrity vulnerability, and you get no details. If you go into the security portal, you may get a CDSS score, which, okay, for most mainframe people, A, if you know what that is, that you're a step ahead of most mainframers, and B, it just has no resonance, right? But if you knew it was a trapdoor vulnerability, it's like, well, wait a minute. Now, when you go to your boss, right, you're the pen tester, and you go to the sysprog manager and you say, hey, you got a vulnerability here, and it's a trapdoor. And they're like, okay, go through the spiel, tell them what a trapdoor is. And it's like, wow, you know what? I'm going to talk to the risk people, because normally in the system programming world, right, the integrity, there's a hierarchy of fixes, right? And if it's not hyper, then it doesn't automatically get put on. Now, there are a few people, and more people are starting to adopt this, but it's still a very low adoption rate, right? They don't put on integrity fixes, right? Systems programmers and the people that do maintenance, they're part of the operations staff. If they're doing things that will make you not 100% available 100% of the time, right? they don't get their bonus, right? It's not in their best interest to proactively, put changes in place unless they have to, right? And given that they have no details, if they put an integrity fix on and it breaks something, they can't explain it to anybody why they did it, right? But with the trapdoor categorization of the vulnerability, you're in a much different position, right? Now you can basically have a conversation saying, hey, here's a trapdoor. It basically allows you any program you want with no control of the installation to get control in DSW key 0. And then you can do anything you want, right? Elevate your authority, crash the system, do whatever, right? So now the manager's like, well, holy cow, that's above my pay grade to make that decision. Maybe I bring in the risk people or everybody else, but you can bring people in. It's not really technical. I mean, it's technical to a certain extent, but the categorization is done at a high enough level that, you don't need to understand all the technical details, but it gives the opportunity for more discussions within the organization. Say, you know what, if it breaks something, we don't care. We really, really don't want any trapdoors on our system, right? And that's something that a lot of the companies that I work with, they actually make that decision, right? So even if it is an integrity and it's not a hyper, and they may or may not have, typically they're all in the security portal or whatever version of security portal the vendors have. They'll typically end up putting it on, but it just makes it life easier and more. The people that put maintenance on, right, they're not basically getting docked their bonus because they put something on and it breaks it, right? Because now the organizations have enough information to make a decision. Hey, do I want to put the trapdoor on? It might break something, but it's like, well, the consequences of leaving the trapdoor exploitable there, as opposed to breaking something and then we have to fix it, right? You're able to make a much better informed decision. So trapdoor, there's storage alterations, there's system instability, and they all do more or less what you think, right? Storage alteration, you get the whack memory. System instability is address spaces start falling over or the system crashes, right? So there's, the categorization is meant to have some resonance with, the mainframe folks, so that when these conversations about patching come up, right? Because patching is the remediation tool that you have, right? You can't make a configuration change. You have to put a patch on, right? So now with these categorizations, you have the capability, and you can also include more people and basically get buy-off from the business side of the house saying, hey, yeah, we really don't want trapdoors on our system. We want them fixed, even though, we don't necessarily know what might break because of it. Storage alteration. It is what it sounds like, right? You invoke a authorized code path and you pass in an address or not, and it allows you to modify stuff that you shouldn't, whether it's in a private area address space of some LX owner, or if it happens to be, just common storage somewhere, right? And just like the trapdoor, you're bypassing the controls of ZOS. There's nothing your ESM can do for a trapdoor, right? There's no SAF call, right? There's no rack route call that says, hey, can Ray do this? Yes or no, right? It's just, the code just executes, boom, you're done, right? Whether it's a trapdoor or a storage alteration, right? Storage alterations are a little bit harder to exploit, but again, they still pierce the veil of integrity, and like the trapdoor, they basically can result in elevation of authority or crashing the systems. But again, right, when you think about it, when you go to the ZOS, either the sysprog or the manager saying, hey, we want this put on, and it's not a hyper, it's like you're basically going to have to justify why to do this. And these categories, at least in track record from the people, the companies I've worked with, allow that justification to be made, right? And I guess that's all I have. Were there any questions?
So, no, nothing in chat. Any questions from the audience? And post your questions if you have any in the chat.
I'm sorry.
I think you've shocked everybody, Ray.
I get this reaction a lot of times. I know it's a lot to take, and it's a very technical base. I tried to bring it up a number of levels to kind of do that, but honestly, yeah, it's unfortunately something else that you have to worry about. But it's sort of like, you know, as the more knowledge you get, the stupider you feel, right? I mean, there's just more stuff that you need to do. And just like the configuration vulnerability analysis, you have to be proactive for it, right? It's not enough just to put your maintenance on, right, and the res cloning and all that other stuff. And there's actually some very interesting things that have come out of this, right? Because, right, I've sort of beat it to death. I said, you know, for these integrity vulnerabilities, right, you have to put a patch on. It's like, well, what do you do if you've got a storage alteration or a trapdoor on your production system, and it's going to take you 12 months to roll the reses to get there, right? And you don't really have a, how do I put an emergency patch on process? I mean, you may, you might not, but, you know, typically most people, even when they have it, are reluctant to do it with good concern. But, you know, compare and contrast that with the forward-facing internet app that the company has, right? You know, they get a CVSS score, I don't know, 7 or higher. You know, it's like the Richter scale. So if you're not familiar with it, the bigger the number, exponentially worse, right? But typically 7 or 8, right? They're basically staying in the office and working until it gets fixed, right? And these storage alteration and trap doors, they're, I don't know, 8.4, 8.6, right? Really, really bad type vulnerabilities. And oh my goodness, it may take 12 months or longer in your environment to roll the maintenance because, right, well, you know, the systems programming staff is all about, you know, uptime and you know, it's, I know it works and it's very reliable. The res cloning, right? You had lots of practice, 30 years, 40 years, even longer in some cases, but it's like, how do we fix this in 24 hours or 48 hours if that's what we have to do, right? And this whole patch management process and how we do it, unfortunately, as an industry, we have to be dragged kicking and screaming into the 21st century, right? So there's quite a bit to the stuff that I talked to you about today, right? And patch management is, you know, important, but, you know, the ability to, you know, get the political wherewithal to put the patches on when you don't have enough information about them, right? By doing these classifications, it helps get the process going. I mean, you still have to worry about, you know, it's going to take 12 months to get there, but you know, it's just interesting when I go to clients and, you know, we start finding these things and it's like, well, gee, what are you going to do, right? And a friend of mine basically said, you know, it's like, Houston, we have a problem, right? Who do you talk to? How do we get the maintenance on? How are we going to roll it? Oh my God, you know, once the auditors find out and we spent 12 months with a CVSS score of 8.6 sitting on the mainframe system, right? Somebody's going to have a cow, right? So there's a lot of challenges with how, in general, our industry does business today. So the evolving of this environment over the next 5 to 10 years is really going to be, in my opinion, very exciting.
Well, Ray, it's Kira. I just have one little comment to make. We did find with one vulnerability, we found, having explained it to management, and then he was asked us how soon would it take us to fix it, and we kind of went, well, it'll take a week for change management. And he went, why? We have this in the PC environment. As you say, they stay late and fix it. He said, well, we can, but we won't get it through change control. And then, well, I'll write them a note. And we did it the same day, and we got, no, I mean, it wasn't a code change. It was a RACF change.
Mhm.
But you know, where there's a will, there's a way. When they understand what the vulnerability is, the way magically appears.
Yeah, and that's the thing, right? With these code-based integrity vulnerabilities, you get bupkis, right? You get no explanation. I got a PTF, you just know it's an integrity. Limited people in your organization might have access to, and I'll just use the IBM model, the security portal, right? But even then, they're restricted on who they can disclose it to, and they don't give you a lot more information. They give you a CVSS score, which, you know, maybe in 5 to 10 years, that'll be, you know, the right way to go. But today it's like, yeah, that explanation is critical. And, you know, it's hard enough to find these things, but then to have to make up a story to tell to get them to fix it, even though you're jumping up and down saying it really needs to be fixed, by automatically categorizing the vulnerability. I mean, this is what I do. It just makes it easier for everybody, right? Once you read them in on trapdoors or storage alterations, you don't have to go through that hoop jumping each time. It's like, hey, we got a trapdoor. It's like, oh yeah, I remember from last time, right? The risk guys are like, yep, go ahead, right? And it just kind of smooths the road. But yeah, right? You don't have the process and procedures in place. And over the years, I've termed that the oh crap moment, when, you know, the mainframe manager is sitting there saying, oh my God, I have one of these things. What are we going to do, right? I mean, they don't know, right? And a lot of organizations that have mainframes, we've got a lot of work to do to kind of get into the 21st century.